All right, and so give the amplitude and period of the function y equals -4 times the sine of 3x, and then sketch at least 2 cycles of its graph. And so this is actually a good point, a good time to point out that if we have y equals -4 or some value times the sine of parentheses 3x, that is the exact same as y equals -4 times the sine of 3 times x. That b value, so b value uh, in either place is the same. So whether it's inside the parentheses, that times 3, or outside, it's going to affect the period in just the same way. When we get to adding and subtracting things, that will be different whether it's inside the parentheses or outside, but we'll get to that a little bit later on. For the b value, for affecting our period, they are going to be the same. So I just want to point out that these two equations, though the first one is the one that's written in this problem down below, it's equal to or equivalent to that second one. All right, so here we go. Give the amplitude and period of the function. So our amplitude is going to be amplitude is equal to the absolute value of -4, our value right here, absolute value of -4, so our amplitude is 4. All right, good enough. So on the graph, I sketched a little graph over here for us. Our max on this one is going to be 4 and -4 because the sine graph itself, its max is 1 and -1. Now we've got that multiplied by an amplitude of 4, and so that's going to be quite a bit taller, 4 times as tall. All right, second, our period. The period is, we're going to use that 3. Remember, period is 2 pi over b, so 2 pi over 3, or 360 degrees over 3. And so we get, well, we can either use this one in radians right here. In degrees, it's going to be repeating every 120 degrees. For us here, it'll be repeating every 2/3 pi in terms of radians. So let's go ahead and sketch this graph out now. And let's do it in kind of a green color here. All right, so sine of 0 still turns into 0. All right, now think about sine. Normally it would be going up from 0. However, multiplying it by -4. And if we go through and think of it in points for a second, our first kind of point of importance would be at 90 degrees, or at 1/2 pi. However, since it's all happening 3 times as quickly now, instead of this being 90 degrees, now it's going to be happening in 1/3 the time, or 3 times as faster. So we'll have at 30 degrees, we're going to end up at -4. Normally it'd be -1, or normally it'd be at +1, but now we're at -4 because that value is being multiplied by a -4. Our next kind of key point there would be at pi, and sine would be back to 0. For us, it's all happening again 3 times as fast. So 180 degrees, that's only 60 degrees for us here. There we are. And hopefully you can start to see kind of our pattern now. So at 90 degrees, which would normally be 270, we're back up to, we would now be at -1, but -1 times -4 is +4. And 120 would be our full circle around. Because remember, our period, instead of being 360 degrees or 2 pi, now it's 1/3 of that. All right, so there's that half the graph looking something like that. And it continue going on. On the other side, and hopefully you can see that that would be just the this here. Don't want to take up too much of your time going through. But that wave would just continue on like so. All right. So hope that helps. And yeah, just to be maybe a little bit more explicit about it real fast, let's think of, let's go with dark pink here. Typically this would be pi over 2, correct? But we're dividing it into thirds. So if I have pi over 2 um, divided by 3, divided into 3 pieces, now that is going to be pi over 6. Where typically this next one would be pi. Again, we're dividing it by 3, so now it's pi over 3. Where we'd have 3 halves pi, or 3 pi over 2, now we're dividing it by 3, getting our pi over 2. And then lastly, where we would normally think of this point as 2 pi, it's being divided by 3, so we get our 2 pi over 3. All right. Hope that helps. Hope that makes sense a little bit. Um, and there you go.